Please give it up for VITALIK Buterin.
Hi. Good morning. Yay, babies. How do we start these slides again? There we go. See, the thing is, people call me smart, but I'm surprisingly ignorant about a lot of things relating to computer hardware. Like, I've never used any of like the old sort of more analog video equipment in my life, and so sometimes there's a bunch of situations where people expect me to be really competent about technology, but then I end up being the stupidest guy in the room in that regard. So anyway, so presentation today is called Liberating the Informational Economy, and the point here is basically to describe a roadmap for the industry, the Bitcoin industry, specifically this idea of crypto 2.0, aka Bitcoin 2.0, aka blockchain 2.0, this idea that it's not just about the currency, it's about the blockchain, it's about cryptographic technology, and how do we take this technology, how do we use it for other applications, how do we make it better, how do we and hopefully, how can we eventually find some kind of product out of all this that people are actually going to use en masse. So, by the way, just in general, how many people here have heard of the term crypto 2.0 or Bitcoin 2.0 before? Okay, a lot. So, first of all, just to start off, we'll start off by talking about is this idea of decentralization. So, the fact that Bitcoin is decentralized is probably one of the most important things about it. It's, we've had digital currencies before Bitcoin for 30 years. We've had databases before Bitcoin for 30 years. And yet, for some reason, people think that there is something fundamentally different about what we're doing here and now, as opposed to, Second Life dollars or beans or flows. So, what makes decentralization valuable? So first of all, there's two kinds of decentralization. The first kind is architectural decentralization. So architectural decentralization basically means that something runs on many computers. So just as Bitcoin is decentralized, it runs on thousands of nodes around the world. There's content delivery networks, the kinds of networks that generally tends to store a lot of major websites for you. They're usually architecturally decentralized as well. They have a lot of servers all around the world, and your computer usually downloads the site from whatever the closest one is. Political decentralization basically means that nobody controls it. So you can't have one without the other. So just to give a few examples, things that are architecturally centralized and politically centralized: Facebook, Skype, most websites, PayPal, Swift, most things in the world. Politically decentralized and architecturally, or politically centralized and architecturally decentralized. Well, Skype was actually originally a peer-to-peer system. Right now it's switched to an architecture that's based more on supernodes, but originally it was just entirely a network of users connecting to each other with no one in the middle. World of Warcraft, a game by Blizzard Entertainment, and the interesting thing about it is that updates to the game are actually transferred to all of the users through a peer-to-peer torrent network. So even though the game is everything about the game, all the software is completely controlled by one company, they are still using a peer-to-peer network to send the data across because they find it to be more efficient. Content delivery networks, RAID is a way of backing up your data by storing it on multiple hard drives. Now, politically decentralized, BitTorrent, probably the first thing that's politically decentralized. Now, what benefit did we get out of BitTorrent? Well, before BitTorrent, we had Napster. Napster was shut down. Then we had BitTorrent, and they couldn't figure out how to shut BitTorrent down. So, it's clear that being politically decentralized has at least one advantage. Bitcoin, decentralized currency. Tor, it's partially decentralized. Like it's got some super nodes, and the network is sort of somewhere in the middle, but it's there. And of course, there's sort of categories that you could say are controlled by many people, but are architecturally centralized, human organizations mostly. So why do we want things that are architecturally decentralized? One reason is we want things to be robust against failures. So if there is some database or some service that I am critically relying on in order to do some very important business critical task, maybe in medical cases even survive, maybe, or in other cases just to keep some network online that's serving millions of people, then keeping it on one computer is not good enough. What if the computer has a defect? What if it breaks? What if in that particular data center the power goes out? What if there's a flood? What if there's one rogue employee that ends up trying to hack into things? Sometimes it's more efficient. So Blizzard uses a peer-to-peer network to send around patches for World of Warcraft. Why? Because all of us together have more bandwidth than they do. They don't want to have to upload stuff to 10 million customers by themselves, so they outsource it to all of us as a group. Sometimes more scalable, same thing. And another potential use case is that it's cost-free to launch services. So basically what this means is that if you are running an application, or if you're running just a website on a server, you have to you have to buy a server, or you have to rent it out, you have to maintain it, and you have to constantly be sure that it doesn't go down. If you launch a peer-to-peer application, runs on the blockchain, theoretically you don't have any maintenance costs whatsoever. So my argument actually is that, or one of my arguments actually is that this sort of last advantage of decentralization is pretty underappreciated. I know, I personally have actually tried to run a Bitcoin multisig wallet, and I've just given up because the server would constantly just randomly have some glitch and shut down every week. So if that was a decentralized application, it would still be up now. So political decentralization obviously means nobody controls it, doesn't rely on any single organization. So what's the benefit of that? So second benefit is the more obvious benefit that everyone keeps talking about. If you use PayPal, PayPal is centralized. PayPal charges really high fees because they're a monopoly and they can afford to get away with it. Discriminatory policies, they might end up trying to censor specific groups of people they don't like. With ISPs, there's this big debate about net neutrality. Even with PayPal, they sometimes end up shutting people out of their accounts for half a year and collecting the interest on them. Lock-in, once you get into a big centralized service, they often have the incentive to make it hard for you to leave. So all the things that we like to complain about, that's the obvious use case. Less obvious one is that things that are decentralized are likely to survive even if their creators stop caring about them. So one of the big problems on the internet right now is this concept of web link rot. So if I wrote a web page in 1995, then someone else wrote another web page pointing to it in 2000, then someone else wrote something else in 2005, then eventually when people browse the internet, the whole point of hyperlinks, the whole point of HTML is that if something references something else, you can click on it and you can see what they were talking about. But here, if I wrote a website in 1995, then in 2002, either I forgot about it or the company that was running my website happened to shut down, then guess what? It's not accessible anymore. So on the other hand, if all of these websites were stored on a decentralized network, then they would basically live forever, or at least for as long as somebody cared about them. So these are basically the fundamental advantages that Bitcoin, BitTorrent, decentralized technology in general have. So Crypto 2.0, or at least the industry that I've started to call Crypto 2.0, the reason why I don't call it why I've specifically tried hard to tell people not to call it Bitcoin 2.0, and why I don't use blockchain 2.0 either, is because this is really something that's much more expansive. It's not just about blockchains. Blockchains are just one single technology that Satoshi Nakamoto happened to invent in 2008. So, for about 30 years, people have been developing all of these different technologies: torrent networks, secret sharing or erasure coding for secure file storage, various different kinds of cryptography. MadeSafe has been taking their own sort of approach at decentralization since 2005. Maelstrom is BitTorrent's sort of a recent attempt to try to create a browser for their decentralized web. Tahoe Laughs, decentralized file storage, it's been a project by Zuko Horn, been around since 2005. IPFS, actually, it's a project to solve, a project by Juan Batiz-Benet from Palo Alto that's actually trying to solve this wobbling problem. So, you know, we have Bitcoin, we have blockchains, we've got Ethereum, we have Ripple, BitShares, and we also have all of this other stuff. And what I see Crypto 2.0 as being this sort of convergence of all of these different technologies working together. So this is basically how. So in general, the way I see this industry is, I see us building a bunch of different services on a bunch of different layers. So, you know, a lot of people like to try to make analogies between the internet that has all of its different protocols on layers. You know, it has TCP/IP at the bottom, or rather Ethernet at the bottom, then TCP/IP, then HTML, or then HTTP, HTTPS, then HTML on top of that. So, idea here is that this is probably the closest that I could come up with to the equivalent of that for the world of decentralized applications. So at the bottom, consensus. So consensus is basically, how do you maintain a decentralized database? So, you know, if you want to have a decentralized application that's interesting at all, you need to have a database for it. It has to have some concept of internal state. It has to progress through time. And importantly, it has to progress forward. You can't have a situation where you can like attack the database and make it go back in time. So that's the problem that the Bitcoin blockchain solves. Now, Bitcoin by itself, it's only one application. Bitcoin by itself can't do everything. So, you know, there are a number of these different strategies for how you can do consensus for applications in general. You can build what's called a meta protocol on top of Bitcoin. You can do merge mining with Bitcoin. You could create your own independent blockchain. You could use other consensus algorithms for that. Ethereum is the platform that we're building, or that I came up with, and that a large development team is now working on. The idea there is basically to have a blockchain with a built-in programming language, so you can build any kind of application inside of it. Subjective consensus is what I call something like Ripple, and a bunch of other more advanced strategies. So, hold on. So, basically, you know, everything that's blockchain-based relies on some kind of consensus. So, you know, there's trade-offs between security, scalabilities, this concept of subjectivity. You know, is there some absolute state that everyone agrees on, or is it more like Ripple, where each individual person listens to all of their some set of nodes that they trust? One chain versus many chains. How do you make? So one problem here is, how do you make things more scalable? So one issue with Bitcoin is, right now, first of all, the big issue with Bitcoin is that the cost is very high. So first of all, there's this sort of static cost of $600 million of basically wasted electricity every year. And on the other hand, every additional transaction on top of that has a fee of 5 cents. So, you know, it's good enough for some financial applications, but outside of finance, people are used to things being free. So if we want to like really expand the scope of what blockchains are used for, we probably need to figure out some way of making consensus cheaper. So proof of stake and Ripple consensus are one approach of bringing down that static $600 million cost, and many chains and sharding are basically how you bring down the 5 cents a transaction. Basically, figure out some design where you don't have every node processing every transaction. Economic layer, what kind of currencies does the whole thing run on? Applications. So applications basically sort of blockchain-based services that live on the consensus layer. So financial contracts, smart contracts generally. Financial contracts rely on data feeds. If you want to have some kind of financial derivative on the price of some particular asset, then you need some way of inserting that data into the data of what the price actually is into the blockchain. Decentralized file storage, it has a blockchain-based component. IBM and Samsung have been working on these applications relating to Internet of Things. So the idea here is, you know, what if certain kinds of devices like cars, fridges, houses, whatever, have sort of blockchain-based contracts that represent them. And so by interacting with those blockchain-based parts on the blockchain, you can actually interact with the devices. So, you know, this idea that you can have sort of like a self-driving car that where you can automatically send a transaction to it to rent it out for a few hours and so forth. So Non-blockchain layer, also equally important. So not everything here is about blockchains. So messaging, Bitmessage, Whisper is something that Ethereum is developing. Telehash is something that Jeremy Miller has been developing for a few years now. File storage, also important. Reputation and web of trust, not a blockchain-based thing, but also, it's an important ingredient. If you're developing a decentralized economy, you need to figure out who to trust. It's a big problem. It's a big problem. Like when you can't restrict who can participate in the system, you have to figure out some way where people can figure out whether or not the person they're interacting with is reliable. And finally, the other key component is the interface of all this. So decentralized applications generally, they're not, the way I see the future of decentralized applications being is that it's not something like you're building on Ethereum or you're building on Counterparty. It's, hey, I want to build a decentralized application. That application has particular needs. What can I use Ethereum for? What can I use Whisper for? What can I use a reputation system for? And ultimately, for these kinds of multi-platform applications to work, we need to have some kind of interfaces. So Mist is another project inside of Ethereum where we're sort of trying to create a browser for the decentralized web that allows people to write decentralized applications that use a lot of these technologies together. Maelstrom is BitTorrent's most recent effort toward doing something similar, although they're not really doing anything blockchain-based. For those wondering why, by the way, I actually talked to Bram Cohen very recently. The basic reason why he doesn't like blockchains is basically, he doesn't like the fact that proof-of-work-based chains are wasting $600 million a year, and he's still skeptical of the security of proof-of-stake. That's, if someone wants to convince him, go ahead. But so, what are the practical applications of all this? What can be a decentralized application? So, mesh networking. So mesh networking, the ultimate ideal is basically to replace the whole internet infrastructure as it exists today, and instead of this sort of centralized internet infrastructure based on internet service providers, we have a system where anyone can participate in moving data packets from one side of the world to another. So, you still have companies managing undersea cables, you still have some ISPs in this world, but the idea is it's an open protocol, it's an open market, anyone can immediately join and become become an ISP. And even on the smaller scale, like with my phone, I can help route messages from one side of a room to another. And everyone participating in this network can get some small fee for every packet they transfer. Now, the nice thing about this eventually this kind of thing can be used to maybe solve net neutrality, maybe provide a very low infrastructure way of wiring up Africa. In the short term, single hop universal wireless access. So the idea here is, I go into a foreign country, I have my laptop out, I do not have internet access, my phone does not have a local SIM card, and how do I get online? Well, guess what? There's 100 people around me. There's 100 wireless hotspots, all of which have passwords on them. And there's 100 people, most of which actually have data plans. Well, why can't I get on the internet when each and every one of them can? Why can't we have a marketplace where I can pick a few of these people, and they can basically act as proxies for me, and I can pay them 0.01 cents per megabyte? So, this is probably, practical application of decentralized technology. You can see it very soon. Decentralized file storage. Storj has got some interesting statistics pointing out how things like Dropbox are often taking 10x or 100x profit margins on the storage that they provide. So decentralized platforms, anyone can participate in a decentralized file storage network. You can participate. You can earn a few cents an hour by renting out spare space on your hard drive. Permanent web is another use case. So this is the thing that IPFS is working on, this idea that, well, what if we use a decentralized network to store websites? And so if you make an article and a lot of people start linking to it, even if you forget about it, other people can continue storing it. Internet of Things, economy of things. So economy of things is interesting. It's this idea of combining Internet of Things and money. So this sort of self-driving car that automatically rents itself out is this one use case that people talk about. More sort of humble use cases are, you can have television billboards where you can use the blockchain to automatically pay for getting your ad up. You could have dishwashers that like automatically order extra refills if they notice that they're running low on whatever resource. Prediction markets, there's a project called Augur, which is currently doing that. So the idea is that people could sort of bet on what the outcome of a particular event is going to be, and other people that wants to know what the market thinks is going to happen can basically listen to the markets and see what people are actually betting. So it's basically a way of listening to people who are putting their money where their mouth is. So those are just a few of the practical applications of blockchains going beyond just money. Now, and there's obviously a whole bunch of stuff involving money. There's remittances, there's finance, there's all sorts of other things. But it's important to keep in mind that we don't have to. There are things that are not financial or that are only semi-financial that can benefit from this technology. So what are our goals? So scalability. We need to make sure that these platforms remain decentralized even as much larger numbers of people start using them. If everyone in the world starts using the Bitcoin blockchain is going to grow to a bunch of petabytes. The only company that's going to be large enough to store the Bitcoin blockchain is Google, and so are we really decentralized anymore? It's a hard technical problem. We need to figure out how to solve it. Cut transaction costs. 5 cents is way too expensive. Privacy, there's a bunch of technologies that can try to make decentralized applications more private. Like one of the other big disadvantages of blockchains is everything you do on a blockchain is public forever. Can we do something that's a bit less public than that? There's this technology like secure multi-party computation. It's been around for like 20 years. It's probably possible to combine it with blockchains in some way to provide decentralized computation that's private. And integration, we need to figure out how to sort of link the centralized and decentralized worlds together. So that's basically my presentation.